The objective of this project is to know the different components used in circuits, and some of these are fixed resistors. A resistor is a two-terminal passive electronic component which implements electrical resistance as a circuit element. When the voltage is applied across the terminals of the resistor, a current will flow through the resistor in direct proportion to the voltage. The reciprocal of the current is known as the resistance, since with a given voltage a large value of resistance further resists the flow of current, as given by Ohm's law. Resistors are universally used in all electrical circuits of devices like TVs, radios, machines, microelectronic semiconductor devices, regulators, etc. Some of these are like this, and the schematic symbol is this. Now, variable resistor. A variable resistor consists of a resistant track with connection at both ends and a whipper which moves along the track as you turn the spindle. The track may be made from carbon, ceramic, or a coil of wire. The track is usually rotary, but the straight track version, usually called sliders, are also available. Variable resistors may be used as a rheostat with two connections, or as a potentiometer with all three connections in use. Miniature version called presets are made for setting up circuits which will not require further adjustment. A variable resistance is useful when we don't know in advance what resistor value will be required in a circuit. By using pots as an adjustable resistor, we can set the right value once the circuit is working. Controls like these are often called presets because they are set by the manufacturer before the circuit is sent to the customer. These are some of these. This is the schematic symbol. Ceramic capacitor. Ceramic capacitors are constructed with materials such as titanium, acid barium, used as the dielectric. Internally, these capacitors are not constructed as a coil, so they can be used in high-frequency application. Typically, they are used in circuits which bypass high-frequency signals to ground. These capacitors have the shape of a disc. Their capacitance is comparatively small. Ceramic capacitors have no polarity. Ceramic capacitors should not be used for analog circuits because they can distort the signal. These are some of these. And this is the schematic symbol. Electrolytic capacitor. Electrolytic capacitors are polarized and they must be connected the correct way round. At least one of their leads will be marked positive or negative. They are not damaged by heat when soldering. There are two designs of electrolytic capacitors. One is axial, where the leads are attached to the edge end, and radial, where both leads are at the same end. Radial capacitors tend to be a little smaller and they can stand upright on the circuit board. This is one of these. This is the schematic symbol. Variable capacitor. A variable capacitor is a special type of capacitor, most commonly used for tuning radios, which allows the amount of electrical charge it can hold to be altered over this certain range, measured in a unit known as farads. Regular capacitors build up and store an electrical charge until it's ready to use. When altering a variable capacitor, the user is actually changing its capacitance. Capacitance means the amount of energy the capacitor can store. A bigger capacitance means more storage energy. This energy is measured in farads, but because a variable capacitor typically has a very small capacitance, a smaller unit known as a picofarad is used instead. These are one of these. And this is the schematic symbol. Inductor. Inductors are coils are linear and passive elements that can store and release energy based on phenomena related to magnetic fields. An application of the inductors consists of Bloch. Science of high-frequency radio circuits gave rise to them with reference to inductors that are used in application where its value is not critical and therefore allowed radio tolerance. Any cable that has a current around a magnetic field with the flow direction of the magnetic field, which establishes the law of the right hand. Being the coil made of wire close, the magnetic field flows through the center of the coil and close its path on the outside. An interesting feature of the coils is opposed to sudden changes in the current following through them. These are some of these. This is the schematic symbol. Germanium diode consists of a piece of germanium crystal and a contact type tip of tungsten wire, contained both in a sealed capsule of glass or bottle. They are very robust and don't affect mechanical shock, vibration, etc. Have high stability and high electrical characteristics. These are some of these. This is the schematic symbol. Silicon diode. Junction diodes consist of a union of two different types of semiconductor materials. The Zener diode is a special type of junction diode used in silicon, in which the voltage along the junction is independent of the current flowing through it. Due to this characteristic, Zener diodes are used as voltage regulators. The diodes have many applications, but one of the most common is the process of converting alternative current to direct current. In this case, use the diode as rectifier. This is one of these, and this is the schematic symbol. The LEDs. The LED is a special type of diode which works like an ordinary diode, but to be traversed by electrical current emits light. There are LEDs of different